Alright, so what we're going to look at today is another definition of acids and bases. In a previous video, we talked a little bit about the Arrhenius definition of acids and bases and how acids and bases can be defined by what they produce when mixed with water. And acids will produce H plus ions, while bases will produce OH minus ions. But this definition you'll see is a little bit more functional. I had to fix my title there. Bronsted does not have an S on the end of it. So this is a new definition of acids and bases. And while the other one is useful, it doesn't talk a great deal about what these things are doing chemically and their behaviors as chemical substances and how they interact with each other. That's what the BronstedLowry definition is more about. So under this definition, acids are now things that donate H plus ions. Another way you could say this is lose H plus ions. You call them, under this definition, acids are called H plus donors. And kind of predictably, I guess, bases will accept H plus ions. So there's not really a lot of talk about OH minuses in the BronstedLowry. They do kind of come into play a little bit here. We'll talk about that near the end of the video, but it's really more about these H plus ions. So you can say that bases accept H pluses or that they gain them. Same idea, right? So this is actually best seen with a chemical equation to work through an acid-base reaction. So let's look at an example here. So say we have HCl, hydrochloric acid. It's a strong acid. And let's say it's mixed with ammonia, NH3. And this is an acid-base reaction, right? So if you look this reaction up, what you would see on the other end, on the product side here, is the product NH4 plus and Cl minus. So this equation here can be looked at, and you can apply the BronstedLowry definition of acids and bases to this equation by seeing which substance is donating the H plus and which substance is accepting the H plus. So if you kind of look across the equation here, let's change colors to highlight some points. You see that your HCl has an H at the front on the left side of the equation. On the reactant side, we have HCl. But then look at what happens to it on the right. That H is now gone, and it's just a Cl minus. So by definition, right, acids are things that donate H pluses or lose H pluses, and your HCl just lost an H plus. So that makes your HCl, according to this definition of acids and bases, an acid. And something similar is actually happening with the NH3, right? On the reactant side, it's NH3, so one N and three H's. On the product side, it's now an NH4 plus, right? So what's happened? We've gained an H and we've gained a plus, so we've actually gained an H plus when this reaction happened. So that means that the NH3 was the base.